Assalamualaikum warahmatullahi wabarakatuh, and a very good day. I would like to bid our Dr. Musa. So today our group consists of Yuvaraj Kunalan, Ong Hui Ling, Loo Jing Lin, and me, myself, Khairul Bin Abdullah, will be presenting about shell middle distillate synthesis sendirian berhad. So as for the introduction part, the main purpose of the plant is to convert liquefied natural gas to ultra-pure liquid fuel, lubricants, chemicals, and solid waxes. Such products are Shell GTL waxes, drilling-based fluids, and chemicals and fuels. And several MSDS we have found about this plant, which is Shell Cerebrine 185V and also liquid paraffin. There are several unique operations occur in the plant, which is Fischer-Tropsch reaction. It is a catalytic chemical reaction which produces syngas from natural gas. Then the next stage is Shell gasification process, then followed by heavy paraffin synthesis, and lastly is liquid processing unit. Next is the geographical information system mapping of the Shell and MDS we have found, which is the location is in Bintulu, Sarawak. Latitude is 3.1667, longitude is 113.03, altitude is 6 feet, while building is 7,000 square per meter. Last but not least, the three scenarios of the plant has been decided, which is the emission of different types of chemicals such as methanol, methane, and also hydrogen.
So now let's proceed to the scenario 1. The two chemical used for scenario 1 is ethane gas. The atmospheric data is referred to the weather conditions in Bintulu in May 2020. The table below shows the input data for Aloha. First, the wind speed is 2.7 miles per hour. The wind direction in Bintulu is west. The weather in Bintulu is partially cloudy with 5% of cloud cover. The air temperature is 89 Fahrenheit. The stability class is class B in Bintulu, which is neutral, and lastly, the relative humidity in Bintulu is 78%. The potential events that might occur for scenario 1 are toxic gas release and also jet fire effect. And now we proceed to the source of strength for toxic gas release event. First, the flammable chemical escaping from the tank, but it is not burning. The release duration for ethane gas is 15 minutes. The maximum average sustained release rate is 35,600 kg per minute, and the total amount released of ethane gas is 545,637 kg. Figure 1 shows the individual risk transfer for toxic gas release event, and the figure 2 shows the graph of level of concern for toxic threat zone. There are three toxic threat zones, which are red zone, orange zone, and also the yellow zone. The coverage area for red zone is 285 meters, but for orange zone, the coverage area is 363 meters, and for yellow zone, the coverage area is 631 meters. So now let's proceed to the source of strength for jet fire event. The burn duration for jet fire is 15 minutes. The total amount burned is 145,637 kilograms. The maximum flame length of jet fire is 99 meters, and the maximum burn rate is 40,800 kilograms per minute. Figure 3 shows the individual risk transfer for thermal radiation of jet fire, and the figure 4 shows the graph of level of concern for thermal radiation from jet fire. There are also three threat zones for jet fire, which are red zone, orange zone, and yellow zone. And this one is different from the toxic gas release, and this is for the thermal radiation for jet fire event. The coverage area for red zone is 136 meters and 201 meters for orange zone, but for yellow zone is 321 meters of coverage area.
Okay, hi doctor. So next I would like to continue on my part, which is hydrogen. So The input for Aloha is the one that's stated here for the parameters, for the 5 parameters or 6 parameters that I stated here. And the atmospheric data, the weather condition is we obtain from the website of Bintulu weather condition in January 2020. So next, the potential events. So these are the two potential events for the toxic release and jet fire. And the next, for the result for the first event, is actually the maximum release rate was 9,150 kilogram per minute, and the total amount released was 16,167 kilogram. So the flammable chemical escaping from the tank was not burning, and the release duration is 5 minutes. So these are the counter plot that we plotted in Marplot and the Aloha. And the red zone for the coverage is 323, orange 403, and yellow is 666. So for the second scenario, the maximum burn rate was 30,700 kilogram per minute, and the total amount burned is 16,167 kilogram respectively. So the flame high result was 34 meter, and the thermal radiation estimate at the point without wind is negative 242 meter of center line 130 meter, and maximum thermal radiation intensity is 1.89 kilowatt per meter square. And the flammable chemical is burning as it escaped from the tank. And these are the red zone that we plotted in Marplot and the Aloha. And the red zone is coverage is 124, orange is 173, and yellow zone is 267.
Next, for the third event, the chemical used was methanol, and the atmospheric data we take the weather condition in December 2020. The wind speed was 3.4 miles per hour with direction north. The cloud cover was 5 tenths, and the air temperature was 86 Fahrenheit. The stability class was D, and the relative humidity was 55%. So there are three potential events, which are toxic release, pool fire, and BREVE. So the first event, flammable chemical escaping from a tank which is not burning. The tank is 5% full and with the maximum release rate of 16.9 kg per minute. The total amount released is 858 kg, and it formed an evaporating powder with a diameter of 24 meters. So these are the toxic threat zone for the first event. So the concentration of the red zone is greater than 7,200 ppm. Concentration for the orange zone is greater than 2,100 ppm, and yellow zone greater than 530 ppm. So the coverage area for red zone, orange zone, and yellow zone are 14 meter, 27 meter, and 88 meter respectively. So these are the risk control plot for the first event. So next, for the second event, which is pool fire, the flammable chemical is burning at its escape from a tank with the maximum burn rate of 94.5 kg per minute. The total amount burned was 2,680 kg, and it formed a burning powder with a diameter of 10.9 meter. This is a thermal radiation threat zone for pool fire. So the thermal radiation for red zone is greater than 10 kilowatt per meter square, orange zone with thermal radiation greater than 5 kilowatt per meter square, and yellow zone with thermal radiation greater than 2 kilowatt per meter square. So the red zone covered 10 meter, orange zone covered 11 meter, and yellow zone 18 meters. For BREVE, the percent tank mass in fireball is 100% with the fireball diameter 382 meter and burn duration 21 seconds. So the thermal radiation threat zone for BREVE. So for the thermal radiation for red, orange, and yellow zone will be same as the pool fire. So the red zone cover 516 meter, orange zone 748 meter, and yellow zone 1200 meter. So these are the risk control plot for the BREVE. Next, I will pass the presentation to Jing Lin.
And now we proceed to the individual risks for methane gas release event. Based on the NIOSH standard, the maximum recommended safe methane gas concentration for workers during an 8-hour period is 1,000 ppm. If the concentration of methane gas release has exceeded the PWM limit, which is the 10,000 ppm, it may lead to severe consequences on humans. The total release concentration of methane gas calculated from Aloha was 400,000 ppm for red zone, 330,000 ppm for orange zone, and also the 65,000 ppm for yellow zone. The high level of methane gas can reduce the amount of oxygen breathed from the air, and this can result in mood changes, vision problems, memory loss, nausea, vomiting, facial flushing, also headache. In some severe cases, there might be some changes in breathing and heart rate, and this can lead to unconsciousness. There are two types of analysis for psychiatric risk. which are quantitative analysis and also the qualitative analysis. The societal risk is typically presented in FN curve, which plots the cumulative frequency of events versus the number of fatalities. This is the FN curve diagram for our event, and the slope of the FN curve is -4 times 10 to the power of -5, and this is also the slope of the societal risk criteria. A risk criteria for which the slope was less negative than -1 was said to be less risk factor. The risk criteria reflected a lower concern for events causing smaller numbers of fatalities, and the FN curve was fallen until the alert region. For the qualitative analysis, the potential reciprocal will be expected within event consequences were inside the fatality itself and also the public near area. The location of this fatality was at the high density area, and for scenario 1 and scenario 2, the events that could discover impact which are injuries and fatalities to those nearby were toxic gas release and jet fire. In the normal operation, there are 5 workers on guard at the petrol station, which is the Shell MDS SDMDHD. During the working hours, the people nearby and the public began to reveal that visitors could be involved in the events too. Although the effect was very minimal, since it was toxic gas release event, but there are still possibilities of flammable area or splash area from the release point that might cause injuries. For the scenario 3, it will bring the worst case scenario due to the occurrence of fire and CLED.
Okay, next I would like to move on accuracy of the result. An article by NOAA Ocean Service stated that Aloha estimate the concentration of gas is assumed that chemical will immediately become a mixture when it released into the atmosphere. Besides that, Aloha is set to achieve the highest concentration of Darwin along the center line in order to let the concentration look like a bell-shaped curve throughout the cloud. Aloha estimate was disturbed when any condition exists that reduce mixing the atmosphere, such as very low wind speed and very stable atmospheric condition. In real life, a very low speed vapor cloud that formed due to the leakage will not mix quickly with the surrounding. So the concentration may be higher in reality compared to Aloha result. Next, Aloha assumed that very stable condition, which normally the stable condition only occur at night and early in the morning. So next is the comparison between theory and limitation of theory. As we know, Aloha is the limitation. Aloha does not take account into consideration in chemical mixture as it only simulates to the pure chemicals. Aloha assumes that there is no wind speed change and steering effect, even though there is a building actually in real life, they will affect the steering and the wind speed and direction. Aloha does not take into account byproduct from fire, explosion or chemical reaction. Aloha is programmed to assume there is no second reaction occur due to the explosion and fire.
Next, comparison with literature. The result from Aloha simulation will compare with real incident that occurred previously in the Shell MDS plant. On 25 December 1997, a major explosion occurred in the ASU which supplied oxygen to the Shell MDS plant. Since this tragedy occurred in December and explosion happened, thus the result for scenario 3 were used to compare with this incident. From literature, investigation showed that an initial combustion event that had occurred in the ASU which caused this explosion. This incident have resulted 12 people injured but with minor injury only. The financial loss was quite serious with 2 product tanks caught fire and destroyed entirely. From Aloha simulation, it was estimated that it would cause 45 fatality, but according to literature, the incident only result 12 minor injury. There was some deviation between the result from literature and Aloha simulation as there were many unknown parameters in the simulation. Besides, Aloha software only allowed the simulations of single chemical, while in the real situation, the tank consists of various chemicals.
Lastly, some recommendations we would like to suggest to improve the safety of the plant. So as for the first one is preventive safeguard that can be recommended is the operator response to alarm by using 3 steps. First, detect the deviation. Second, diagnose the condition. And lastly is to implement the solution to solve the problem. Next is the emergency shutdown valve should be installed in a plant to isolate the flow when there is any signal interruption in the plant. Next, as for the mitigative safeguard, the installation of flammable vapor detector is very crucial in every chemical plant, since most of the explosion of fires begin with the formation of flammable vapor. Next is the emergency response plan should be developed in the facility to help prevent fatalities or injuries and protect environments and community during an accident. So that's all from us. Thank you.